what I like to do when I teach systems is by graphing is that first of all I like to break it down into a problem that students may not think about as a system. So if you read through this, the snack company is trying to market a new snack, and it's trying to keep a cost at $4 per bag. So there's certain things that are given in here. For example, the cost of a pound of nuts is $1 and the cost of a pound of dried fruit is $2, and the company would like to keep the cost of the bag at $4. Now at the same time they want this thing to taste a certain way, so to control the taste what they want to do is have twice as many nuts in the mixture as there are dried fruit. So I asked the students to then determine by guessing and checking how many pounds of dried fruits and how many pounds of nuts should be used in each bag, and it really doesn't take them too long to figure out that it's going to be 2 pounds of nuts and 1 pound of dried fruit, and when you do a guess and check you can see that the equation will be at $4. Next, what I do is we actually write those equations out in terms of variables. We model out the problem by introducing certain variables. We let the y represent the pounds in the mixture of nuts, and then x represents the pounds in the mixture of dried fruits. And then in number 1, for example, we can write the equation $1 times y plus $2 times x equals 4. The $1 is the cost of pounds of nuts in the mixture, and the $2 is the cost of dried fruit in the mixture. Next, we can go to the taste. Since we know there should be twice as many nuts in the mixture as there are fruit, we can write the equation y equals 2x. Next, what I like to have students do is then put both equations in slope-intercept form and graph them. And then we can relook at the graph in terms of the intersection of the two equations, and in which case you could see that the solution to this system will be 1, 2. Okay, so that re-verifies what the students did in the guess and check. Next, I have them do general systems where they just look at the slope and y-intercept graph and state the intersection. Then I do some in standard form where you have to solve for y first. Then we look at special cases. For example, the case when there's an infinite number of solutions and the case when there's no solutions. In the infinite, I like them to notice, for example, if you look at example 5, the multiple of 2 in the situation. If you multiply the first equation by 2, you get the second. Similarly, if you divide the second equation by 2, you get the first one, so they get an idea that it's the same equation. In example number 6, I like to point out that you see the same slope. If they have the same slope, they're parallel and they'll never intersect. And that's it for that one. And then I like to summarize all the different situations that can happen in terms of the number of solutions. Next, I have them do some mixed problems, ones that have a solution, ones that have infinite, and ones that do not have any solutions. Okay, I also like to put in vertical and horizontal lines, as you see in the example on the left, just for extra practice, and later we'll use that horizontal and vertical lines when we introduce substitution. And this concludes the presentation of Introduction to Solving Linear Systems by Graphing.